light up your eyes. Hopefully you can hear me across the whole room. You've got plenty of space, which is good. So I'm not going to bother talking too much, just going to introduce. We've got a few people due to come in, but they'll just jump in when they come. I'll just hand you straight over to Neil. Kick things off.
Sorry guys, got bear with me. I've literally just moved over to a Mac from a PC, and I'm having some issues with virtual machines, and it's all these kind of connections, so bear with me. Yeah, thanks very much for the opportunity to come and speak to everybody today. There we go. Okay, so just as a quick thing, I'm going to take you through some NI Linux real-time tools, and I've called them hacks for the second part as well. They're not necessarily hacks, they're just things that I've found quite useful so far. I've brought some equipment with me as well, and to actually hopefully give a bit of a demo of some of the stuff that I've done. So I actually have one of these compact wheels in front of me. But as a quick introduction, my name is Neil Crossan, and I'm a senior test systems engineer, and I work at Dyson Technology Limited. I want to start off by maybe giving you a quick overview of what we do at Dyson, and a bit more of an overview of the technology that we have at Dyson and the kind of testing that we do. So I wanted to highlight this slide here. It's a slightly older slide that we've got, but it basically gives the timeline of Dyson up to 2018. So Dyson Technology Limited is the company, what work that we actually do. What I mainly want to highlight here is the fact that you can see, or maybe you can't see, this way, there we go. You can see down here back in 1993 when the company first started, the only thing we made was corded vacuum cleaners. So the Dyson DC-01 was released in 1993. Then move on to 2000s, Dyson actually made a washing machine. People know that Dyson used to make washing machines? Now, it's kind of good that people don't know Dyson used to make washing machines. They were great for the technology at the time. They were just a little bit too ambitious to be something as reliable as we expected of the Dyson product. So it's something that was pulled from the market after about 5 years. So the washing machine in 2000. And then fast forward through 2007, we added some additional categories. So we've added on in 2007, we've added on the environmental control, things like the hand dryers as well, and handhelds, into corded stickbacks in 2011, through to personal care in 2016, which is one of our brand new categories we moved into, which is things like the Dyson Supersonic hair dryer and the new air wrap styler we moved into. We have lighting as well. You know, we make desk lights under Jake Dyson to make desk lights. It's Jake Dyson, so it was the Jake Dyson lighting company originally, and it's integrated in the Dyson brand after that. We have a robot vacuum as well, we launched in 2014. And then up until 2018, where these numbers go to, we had the V10 cordless vacuum fit in 2018. We expanded in environmental control to have purifiers that can purify things like formaldehyde, for example, as well. But the main thing I wanted to leave this graph up here is more just to talk about how products have become more and more advanced over time. If we think back to something like the DC-01 that came out in 1993, as a test engineer, which is where I work in full product test, the only thing about the test with that was when you press the mechanical switch, does the machine come on and off? It's a bit more complex than that, but that was effectively the only test in that product. You press the button, does it start, and how much suction does it actually generate in that time? It was pretty much the end of the test. If we fast forward all the way to 2018, or 2019, we launched the V11 Absolute handheld. It has a touchscreen user interface on the back of it, advanced filtration technology, it has wireless connectivity, it has a special torque head that changes depending on what surface you want to type. You go from hard floor to carpet, for example, it automatically ramps the suction up or down, depending on what the resistance it feels at that time through it. It has battery technology, it charges, it's connected to the internet as well as a connected product. All of these things require testing. So the job that I do is getting more and more complex as we move forward. We can no longer make simple test rates. We have to be dynamic and changing the actual product. And that's just in floor kit. That doesn't cover any of the other products that we launch. So this slide here just highlights a little bit more about some of these things. We've seen the advancements in the technology in terms of hardware and in software. So we talked a little bit about some of the things we have to test now, like batteries and power electronics. Filtration medium also needs tested at different degrees. When we look at our purifiers, we talk about things like the new ones can purify formaldehyde. We have to have a way to be able to test that. You can't write on the box, this rate purifies formaldehyde, without having a way to be able to test it. And I know this because we also check this with competitors. If a competitor says, my purifier purifies formaldehyde, you can guarantee we're going to buy one, take it apart and see if it does purify formaldehyde. Same as they do to us. If you want to write something, you've got to look through it. We have a look at things like the software as well. Products are now connected products. We connect to your Wi-Fi network, we speak to Alexa, we do all of these things. The products are getting much more complex. We look at things like the robot in particular, one of the most advanced systems we have. It has a vision system for object avoidance and object tracking, along with all the sensors you'd expect to have in a robot vacuum to make sure it doesn't fall down the stairs, for example, and a lot more, as well as being a vacuum cleaner at the same time. So as an overview of Dyson globally, we have a global presence as a company. I myself work over here in D9 down in Malmesbury, which is the main facility we have. It's the head of the company. Singapore is now the head of the company, the previous head of the company. We do also have the Singapore Technological Centre, and we have Malaysia advanced manufacturing, and the Philippines as well, which has been brought online now. So we look at things like the Malaysian Development Centre, it's where half of my team sits. So I spend some time there in Malaysia as well, so it's in the UK. Over here, we have the actual Dyson campus. So this is D9, or New Product Innovation, that we have inside of Dyson. It's a large glass cube. I affectionately refer to it as the Crayola cube, mainly because it's where we keep all the blue sky thinking of cardboard cutouts. Everything's made using Arduinos and as cheap as possible because it's just new product innovation at that point. So I call it the Crayola cube, not Dendy's face, the fear of any repercussions, but it's where they keep all the kind of new products that people are working on. So it's very low budget, complete development. Most things are inside this cube. If they make it out to market, you're talking, this is probably 5 to 10 years ahead of the products we actually have in the market right now. So this is what we keep in this building in here. And they're doing some cool stuff. These are some other engineering icons we have around the Dyson campus. We have an Olympus engine out of Concord in our Concord cafe. We have multiple minis and mini Coopers around, one in Singapore, the UK. We have a Pegasus, a Rolls-Royce Pegasus engine as well, down here. A Whittle engine. But my actual all-time favourite is the English Electric fighter jet, which we have suspended from the roof in one of our lighting cafes. So actually in the cafe where we have lunch, there's a full-size English Electric fighter jet suspended from the ceiling. And we do have a Harrier jump jet out in front as well, which has got a great story with it. So there's plenty of engineering icons dotted around all over the cafe. It's quite a cool place to work. Okay, so that's enough about Dyson's and the propaganda that goes with that. I want to go through a little bit about some of our historic test rigs for Dyson, and these are test rigs that I've seen after I've joined Dyson or coming into the company. They're quite often Windows or some kind of custom-made control system. Sometimes PLC, sometimes just old-school contactors. I want to test rig this, and I want to go through some of the problems that we've had with those so far. So as an example of 2 test rigs that we've got, this is a test rig we use for testing the new airback styling. And what we can see here with this particular setup is all the controls are actually contained. All the controls are actually contained up here in this box. Okay, so the actual user inputs into this test system are all this predefined system that we have. So we've got things like our start button, foaming the motor, changing the actual length for it to move through as well, so the switch between the 2 positions, and then obviously our e-stop system. All of these are just dumb switches that connect down to originally the PLC, a compact rig for a setup like this. And it all connects down into a compact rig system that manages the control of this particular test. All it does for this test is, the way the air valve works, if you haven't seen it, it uses a coanda effect, that if you hold long here next to it, it wraps itself automatically around the barrel. So all this does is effectively lower the hair down instead of moving the product up, and we check to see does it manage to maintain that constant loop, that constant curl around with something like this. Here's another example of one of our sometimes neglected but most important test rigs at Dyson. This is a push-pull rig, and it's used for testing vacuum cleaners. So it's probably our bread and butter, even now. And it's what you use to test the independent standards that you have. So whenever you make a vacuum cleaner, a corded one has to conform to certain standards for energy efficiency. You know the labels you used to get, say like A, B, C, etc. They're tested on a rig like this. what is their performance like involving the load, how much power they actually drawing at that time on a program like this. These do all the IEC standards that are across the world, global standards, in terms of pickup performance, and it's how we compare our products to competitive products with a rig like this. The setup here, again, is things like with a Festo drive for controlling the main motion. There is a compact wheel in the system as well, but there's also up here, this little touchscreen is one of the NI touch panel PCs, and they were used one of them before. It is Windows 7, but they were slow when they were new, and this thing's like 8 years old, so it's painful for a technician to actually get up and running. And it's based on Windows 7 embedded. It's not the best situation we've got at the moment. So there are a few problems with setups like this, and some of you may have already identified them. One of the problems we've got here is Windows 7. Does anybody know what's happened to Windows 7 recently? They're making IT departments really upset everywhere globally. It's been end of life, right? It's end of long-term support for Windows 7. So our IT department, with infinite wisdom, have just forcibly ejected all Windows 7 machines from the network overnight. Now you can connect to the network, can't get any network drives, you can't access all my resources, just off. No backup plan, nothing. Great. I suppose I should precursor this by saying we don't have a good working relationship with our IT department. Does anybody have a good working relationship with our IT department? Yeah, they're all blockers. And I understand why. Like obviously in their world, like in the same with like they brought some new rules for the same things in banking. In their world, it makes sense. Windows 7 has got security breaches in it now. They just offline. They don't understand fully our sites. We're working on that relationship. But our IT department don't quite get why just taking them all offline is actually costing them thousands of pounds per day. So that's one thing, so Windows 7 being end of life. This is the second problem that I have. So they provided us all new desktop PCs for Windows 10, just swapped all the computers and dropped them off, and they're expecting now just to drop and replace. Now, some of these test cavities were set up back in Windows XP, which is a standard operating system, so they're incredibly old. And quite a lot of them are MixieLink PXR. Have anybody's ever had the pain of dealing with MixieLink PXR? Anybody who worked at NI definitely has, it's all you get support requests about. It's effectively how you connect the PXI chassis into a Windows-based machine. It's an expansion bridge. And they don't work properly. Well, they do work, but just not great compatibility. And what we discovered is when we moved to these Windows 10 machines, they don't have things like PCI cards. They're all PCIe. Or they're ultra small form factor and there's no expansion slots at all on the back of them, which is meaning that these PXI chassis aren't compatible. Now there are some options. I can switch to a Thunderbolt controller. I'd have to change the chassis as well. There's a lot of cost involved in making these changes. So we have a lot of incompatible drivers. The other downside is these test systems might not be only NI stuff. There might be additional pieces of software running on that rig that it also needs to access from time to time. So we have incompatible drivers for those. This one is another one of my pet peeves. And it's particularly impactful to us as people quite often archive a piece of test equipment or put it in storage temporarily while we work on something else. And when we have something like this, we bring it back out of archive and turn it on. It has to have the latest version of Windows to be allowed back on the network as per our IT department and their rules. So you have to wait for it to update. If you want to do a quick measurement or a quick test, it then becomes not quick while you wait for it to update at the same time. So it's another one that kind of gets this. And then the last one here, the reason I've left this image in here is I'm thinking more here about incremental upgrades to pieces of test equipment. So if we think back to the picture I had a while ago, this rig, remember I said it's got a custom control box to be made for that rig. This rig you see here wasn't actually designed for the air rack. It was actually designed for the Dyson Supersonic air dryer. And this little switch we have here, it's got different lengths of hair. There's a little switch just over on this side here. This switch here, it's got two settings on it. It's got one for 40mm and 35mm lengths of hair. That's the two lengths it's predefined to handle. Now, when they brought out the air rack, the design engineer went, when we designed it, it needs to be able to take 45mm of hair, as well as the other two we already have. So we can all see where we're going with this, with the level of change we've got to make here. The compact wheel is in a box like down here. Okay, so we've got to crack open this box, run additional cable, change the switch for a 3-position switch, run additional cabling down to the bottom of the compact wheel, and reprogram the compact wheel to handle that new stage, and the Festo actuator along with it as well, to have it handle everything together. Which is why I've left this image in here. This is actually a legitimate image of a test rig that's had multiple incremental changes over time, and we've taken the back cover off to get something, And it's like someone got a bunch of Christmas tree lights and put them in a washing machine and then expect them not to be tangled when they come out the other side. Absolute nightmare. All the cables are labelled, but it doesn't help because you still have to try and find where the end of that cable is at the same time. This is an example of where incremental upgrades can be incredibly costly in the long term when you try and make these changes. And as a company which is constantly innovating with the technology, we need to be able to change these test rates on the fly as the requirements come through. We can't have them be fixed in functionality usually. This is the last one. My computer hasn't actually blue screen. It is a Mac, so apparently it didn't do that. This is the last one here. Things like blue screen of death. As a company, one of the main reasons of blue screen of death is things like overheating of computer components. So if you can imagine, the only way you can get a Windows machine is to buy it from an IT department, and they only have two options: a regular desktop. Sorry, three options. You can have a desktop, a laptop, or you can pay 30 grand for a server and you won't have access to it. Okay, so obviously you get the desktop, and it's not dusted. Now, as a company, not only do we test a lot of dust, we buy dust from all over the world. So we're actually constantly injecting dust into the environment. So we're accelerating the process. They overheat, blue screen, start again. You've got to take the whole thing apart, strip it down, see what the problem was, and bring it back. Annoyingly, nicely, if you do get a blue screen, you then get greeted by the BitLocker death window, you know, the one that comes up and says, please enter your book. I don't know what the password is, IT won't give it to me. So you have to get an entire new desktop PC if you want to get that test rate back up and running again. Now you ask me, this is not a way to live. Okay? This is causing a bane of my life, this setup. So a lot of the investigation I've done on the new type of test rates we put together comes purely from the frustration of having to deal with our IT department. So really it's a double-edged sword here. So the solution, in my opinion, is full Linux test rates. So before I go any further, has anybody actually used these types of compact routes before, 9030 and 9040? The ones that have to tweak? I see a couple of them. Okay. I'll do a couple of demos in a minute how they actually work, but what I want to go through first is to start. First disclaimer, I am by no means not a Linux person, okay? So it's like, what I've done so far is just by pure trial and error, Googling error codes, that's about it, is all I've been able to go through, or finding KPs online. I'm not a proper guru. I do speak to some people at Dyson that live and breathe Linux, and they just quote things at me. I just use Stack Overflow, okay? So full disclosure, I don't really know what I'm doing when it comes to Linux, but I've managed to get quite a few things working, and I've rewritten KPs specifically for them, so it's just a bit of disclosure. If anybody does use Linux as their everyday thing, I apologise for getting it in there wrong. Think of me like someone who's done like 2 days of Core 1 and speaking to a bunch of architects. That's usually what it's like, to be honest. So this here is actually an example of one of our completed full Linux test rates. So this entire rig is running off of a single compact video 9030. Inside the rig, I've got a video I'll show you in just a minute. We've got network attached RAID storage for data capture, just network attached hard drives, and for data storage, 2 terabytes of storage. There is a NI rack mount DC power supply, so 1,500 watt DC power supply. There is a on-run safety PLC inside here. We have a touchscreen, 2 motors, some EtherCAT-based data acquisition called Remote I/O. I think I'm the only person in the UK that buys it, but Remote I/O EtherCAT-based data acquisition, along the top of this rig as well. And the way that this full rig works, and there's an interlock system as well as part of it. And there's no windows whatsoever. The configuration from the rig is all done directly on the rig itself. You want to change the voltage output, you want to change how long the rig's on for, off for, on times, everything. Even connection out to the main fast thread systems inside the lab is all done directly with the compact rig. There's no other configuration on this rig. Just a quick video of it working here. So what actually happens is the robot vacuum, I'll show you a bit before. It's a robustness rig for testing the robot vacuum. So what we have here is a conveyor belt that contains 3 different surfaces. We have carpet, hard floor, and then vinyl. Apologies for my shoddy camera work. And what the robot does is the robot moves forward under its own power. It's connected to a gantry. At the top of the gantry, there's a small ultrasonic sensor. As the robot gets closer to the front of the belt, it speeds the belt up to keep it in the middle. The robot slows down, it slows down the belt to keep it on the other side. So effectively, the robot is kept near enough in the middle of the belt. Up the top, there's also another belt that's used to drop dust over time. And this rig can be configured to run for 20 minutes, all the way up in increments up to 72 hours completely unmanned, and it will just acquire data for that length of time. Now, as you can imagine, would you trust a Windows system to run for 72 hours continuously? No, right? Maybe your UI, maybe you could sacrifice, it's not going to be working when you come back and get it. But absolutely everything is being done to the system here. And what it has in it as well is I'll make myself feel busy. What it has in here as well are 4 pressure taps in the top box. We've got a bunch of thermocouples as well. There's a good story about the pressure taps. I'm sure Ingram would appreciate this. This is actually one of Ingram's original rates before when he worked with ISO. But when you buy pressure taps, if you make vacuum cleaners, you have to buy the ones with the negative bar, not positive bar. First mistake I made when I worked with ISO. Apparently a vacuum is the opposite of what it was. That was an expensive mistake. And also 1 bar is also a ridiculous amount of suction. This entire system as well does actually run off of, you can just see up in the top corner here, but I'll have some more pictures in a minute. The user interface is running directly from Compact Rail. Okay, so the touch screen, the user interface, everything's running from Compact Rail. And that's what I have here as well. And if I can get my Windows virtual machine to connect directly properly to it, I'll show you how you can actually enable and use the Windows virtual machine with the connected UI. And it is so easy, it's unbelievable how easy it is to connect to the UI. Okay, so we'll get to the connected UI in a minute. I just want to cover some built-in tools for those who've maybe not seen one of these units before or used the Linux Compact Rail. So one of the big benefits we've got are things like the web configurator. People seen the web configurator before? Right, so the web configurator is a way, it kind of looks a bit like NIMAX, right? But it's actually from inside of a web browser. So you can connect to the Compact Rail directly. You just go to its IP address, as long as your computer is not a dicey computer locked on. You can connect the computer's Compact Rail's IP address, and you can see all the features of the Compact Rail. You can upload files from it, you can download files, you can change some basic settings on it as well, and you can check to see what state it's in at that time. Big advantage for us is you don't have to have NIMAX installed to do this, nor do you have to have Rio 15 or whatever version of Rio you're using at the time. You can just connect from any web interface, or even from something like an iPad or a phone, for example. You can get to this web page as long as you're on the same network. So far, I've been okay. As long as you have Silverlight, but you can do Microsoft Edge on the iPad and install the Silverlight add-on.
How does that work?
Yeah, I thought that would come up, yeah. As long as you have Silverlight, it's a big disclaimer, Silverlight's going to end a lot for a lot of stuff. But as long as you have Silverlight, then you can get access to it. Another one I want to talk about is the SSH client, which again I'll show you in a minute. It's how you can remotely access into the target. So this is an example of using PuTTY. If you're on a Mac, you can just use the terminal directly. You can connect to the Compact Rail as an admin, and then that's how you can install additional pieces of software in the Linux environment. You can check things like you connect to it, you can check things using a command called pop. For Linux, it's effectively the equivalent of Windows Task Manager. It will show you how much CPU usage is being used, how much RAM. It will even show you down to which VI is currently using it, not built-in executable. Pretty good way of doing it. And obviously you should use things like real-time desktop execution trace toolkit, whatever it's called. This is a very quick way to be able to see if it is actually going to be memory leak, and you can just check it throughout the SSH line. It's good for checking things like IP address as well. It's kind of like command line on Windows, so you can just do ifconfig, and it'll give you all of the IP addresses for everything you've got connected. For us, that's quite helpful. Quite often we'll run the Compact Rails with both networks, one for the internet, then an intranet inside the rig for 2 adapters, and then possibly a third one as well to get onto a lab network, so a USB to Ethernet adapter, which works flawlessly just out of the box, plug it in, and that'll give you another Ethernet port you can then use. Using these commands, you can then see what they're all set to, their static IPs, etc., and else, and if they're connected, what data is being transferred. Okay, so the absolute game changer and how this is so easy is things like the embedded UI for Compact Rails. As I mentioned there, we actually have a touchscreen that's connected directly to the Compact Rail. The Compact Rails, as of the 9030 and above, so 9030 and 9040 CCs, support display out. So you can either do the display port or the new ones are USB-C, which is kind of annoying because I don't know if anybody else has got the problem, but I can't find an industrial grade USB-C volume connector to go through the panel mount anywhere. I can get DisplayPort and VGA and HDMI, but USB-C is a nightmare to try and find for a good panel mount. So if anybody has one, a good panel mount USB-C, I'm definitely open to suggestions because I can't find a good one. You can actually then get display out directly from the Compact Rail and then touchscreen connection as well to have it. So what I'll do is I just want to give you a quick demo that you haven't seen before. So for the demo, we're going to land, we're going to see this screen down the front. If that's right with me, and I just kind of hope and pray it does what I want. So, wait for the compact. This is the compact rear 9040, which is the one I use for majority of development. And with a bit of luck, it should go up in a minute, but it should also not have read facing it. So as you can see, this is a screen that you may have seen previously. We've got a file app or a Linux-based PXI system. You get greeted by the screen, it usually shows you what's running on it, just a blank in the console out. Now, if I, for example, want to just see a bit more detail, so it says, apologies in advance, this doesn't work straight away because this is a virtual machine. So, open up NIMAX to connect to the actual hardware. Oh, fantastic. So, somebody get your Zoom ocular term. Okay. Use another little helpful tool that you guys haven't come across before, the troubleshoot remote device discovery tool. Actually, it is, in my opinion, incredibly powerful. Because in situations like this where I know what the compact root's IP address is, it's not showing up it's disconnected, you can use this tool built into NIMAX, and it will actually scan through additional subnets. So if you have additional subnets connected or even a virtual machine, it goes past a bunch of firewall rules as well. It's all written in LabVIEW, but it's a great way to find something. Particularly if the device is not functional, like if it's in safe mode, no software, this is a really good way to force into the actual target. It's got a bit of a jam for a few times. As long as you don't use it on 2017, as on 2017 it crashes on launch. As a known bug, and the solution is upgrade to 2018, I think. Okay, let's see if this works. Disconnect the system. 2 seconds. Disconnected.
Just connected to the building.
That's the correct noise. There we go. On the other virtual machine, it never seems to remember what the IP address is.
Being any like that,
Well, you just wait for what's going to happen in a couple of time. Yeah, because this is it seems to get not supported by an I section until it varies. Oh, hasn't it? Right. So, if you think of virtual resolution up there, you can see what your screen actually looks like. There you go. So as you can see, you can see it facing the back there, and I still can't see it, but the remote device discovery tool is like, yep, there's a compact there, right? And if I just hit next, it then will force NIMAX to connect to that target, even though NIMAX is secondary says something. basically, instead of NIMAX, there's a little tick box here that says Enable Embedded UI, and then I'm just going to hit Save. So we don't max so much of it. I target saying reboot. Hopefully. As you can see, I've installed quite a lot of stuff on this compact video while I've been messing with this demo, so it's not the fastest.
It's always twice as long as this, unfortunately.
As long as it's not the slowest part of a test rig, as long as there's something else takes longer, like an AC source takes longer to heat up, then it's fine, you get away with it. It's like my mantra when it comes to building test rigs. As long as your test rig, if you've got memory leak, as long as the sample and the test fail before the memory kills the system, success. And there you go, now I've enabled the embedded UI. So you've actually got a full graphical user interface, directly here on target. I've got access to some other tools I'll show you in a minute. But the really cool thing I want to show you is made some demos out there, and I don't know if anybody has previously used something like some kind of way of getting a display on a compact video. A couple of options. You can either use a Windows UI and then use network published shared variables between the two, but you have to maintain two applications, so we'll do that shit. Or you can use assembly done the little Android displays or like RS-232 displays. It's well the pain, right? You have to work properly. You've got to try and design something to work on an RS-232 display, and it's just not very intuitive, in my opinion, anyway, but it work. I don't come from the world. So what I'll show you here is actually how you can get something to show directly on that user interface at the bottom. So a couple of things. So now I have the LabVIEW done as well on a virtual show. But yeah, in terms of these things, of course. This is a lovely IT department really helpful. And also that working out there disconnected license to be on the VPN, but the Mac doesn't support the VPN, so I put together a really simple so simple. Right. So I've got my compact video here, and I put together this really simple demo, which is simple add two numbers together. Okay. And all I'm going to do is I've just opened it from the compact radio, and I'm just going to press run. It's going to connect to the compact radio, and then with a bit of luck on that display, you should see that it's now opened that panel on that display. It's as simple as that. There's no additional configuration that has to be done around that. What I have here is going to be exactly what's on that compact radio. Now you probably can't see it, it says the local control component, which means if I make any changes here, so I change my numbers, for example, here, if I simple add, it then works instantly on the compact radio screen. So I can't see it, you've seen a lot of nods, I've seen that happen. And that block diagram is very simple, just add two numbers together sometimes. I've got to be on this side, so it's really not complicated. Now we can take that one step further, and I stole this from Mavic Core 3. If we have a look at something like this stopwatch that I've got here, relatively more complex graphically. Hit run. And you should be able to see that that's actually running the graphics on the compact view as well then. So there's a couple of huge advantages with this. It means, for example, this compact view supports things like event structures. Compact view don't support event structures, but the ones with embedded UIs do. They support event structures, they support invoke nodes, property nodes, pretty much anything you can do on Windows. There are a few limitations. I've yet to run into a proper limitation, but everything seems to work as you would expect on the actual target itself. If you build it into an executable, you can then take control of it from there. And if, for example, I was to go to my project here and I right click and I just disconnect from here, hopefully this works. And then actually complete control of the unit can then do complete control of it. Once I get my mouse. It's from here. So I can actually run this VI now as if I'm directly connected to this target. So if I had a keyboard and mouse connected, I could complete control that target from here. So it's a huge benefit. It's incredibly quick then. Particularly if you set up a separate UI module, you can then just access it. You can just have that module launch as your front panel, and you don't have to make any changes. You can run everything as you would do. I didn't put in timing this VI, so it's not happy. There we go. So you can connect directly from one device straight onto the compact router and have that UI module.
Sorry, so what configuration do you have to do in order to get other than enabling the embedded UI?
Yeah.
To be able to get the UI to display.
Nothing. Just enabling UI. Yeah, same as you do dynamic execution from a compact view, where you like run in real time while it's still connected to the target. That's all I've done in this situation here. One other cool trick that I can show you that I didn't realise was really a trick, I've just always known it, but from here, I don't know if you've seen this, you might have looked up here, but you can actually, you can have a VI open on Windows. This little banner on the bottom, if you right click it, you can choose to run it on Windows or on the compact view, if you've got the same VI in both places. So for us that do development on Windows, and then deploy to the real-time target, you can have the same VI. So you make a change to one, they both update. So you might have ever seen my project, but it actually has identical copies of both. Run it on Windows or run it on real-time. It's exactly the same VI. If I change one VI, it changes both VIs to that point. It's a really good way of being able to do it. So if I change it to run on my computer, for example, and now I run it, hopefully the one in front should then be updated. But if I instead stop it, and I do open on compact view target, and run it, and then it deploys onto the compact view. So you can run it on both targets inside your actual computer. That should then run on the compact view. And this VI itself is relatively complex. I mentioned it supports event structures, etc. Look at the block diagram. Not only is event structures, it's user events and front panel objects with custom controls. And that just worked natively out of the box. And after tweak anything, the other thing that's a slight difference is obviously the font they're using for the text here doesn't transfer across. We'll come back to that later, but there are some limitations when it comes to designs, etc. for it.
Sorry, excuse me,
Yeah.
You can use event restrictions.
You can, yeah.
Without the event UI.
You can use user events.
User events, but you can use exactly. You can use front panel objects that we've got here. For example, on that's a good point actually. On this one again, in here in event programming, if we do event method event programming, which is stuff that we call one, I think. I run that on target. And I do things like check time or acquire data. It's updated in real time then. Press stop. We have a block diagram for that, which is an event structure. So regular event structures also work because you have front panel objects. So you don't have that limitation anymore when you have a look at it. If your analyzer does drop the error, you analyze it, it does say it might not be compatible with real-time targets because there's only a small subset of them support the native UI.
Yeah, like the old controls just look slightly different. Or
Yeah. I'll show you in a minute. I've got a few ways where we can get around that. But yeah, it is a problem. We'll cover graphics in a minute. I've had some extreme cases of UIs not being correct. Which isn't helped by the fact that Mac licenses use access custom fonts, not regular fonts, which obviously only exist on our computers and don't even exist in any other repo anyway. So, good fun. Okay, so that's all the things that are natively supported. Okay, so everything I've shown you so far, you can do out of the box from NI, and they give you all the documentation to help you do it. What we're going to go over now is what I'm calling hacks. And I've heard this gift of Hacker Man. They're not necessarily hacks, they're just things that you probably shouldn't do to your compact view, or if you do it and you try and call up NI for support, you're not going to get any support from NI or these kind of things. Some have been taken from the NI forums directly, some I've just worked out by myself, and some have been taken from other things that I know work on Linux, and I've just attempted to do it on compact view. It is based on a Linux build, so a lot of stuff does work, just a few limitations. So the first one I want to cover is admin rights. Nobody's done anything with Linux before. It's a thing called sudo in Linux, which is how you do anything. It's equivalent of running as admin for Linux. And I quite like this graphic. If we have an experiment with Linux, this is exactly what it's like. You ask it to do something, it basically says no, or not, it doesn't even say not authorized, it just says command not found, usually, something really unhelpful. You put the word sudo in front of whatever you're trying to do, then we get a problem. Like trying to get your IP address, you go ifconfig, it goes ifconfig not found. If you do sudo ifconfig, it goes yep, use your IP address. Now, to me, this is not intuitive, but maybe it's just the way that I'm wired up. Now, the reason I bring this up is when you connect to the compact radio via PuTTY, the login is admin, it's usually admin blank, the default. That one is actually part of sudo, so it can access sudo and do all these commands you'd expect at that point. However, there's a really helpful tool inside of LabVIEW called the System Exec VI, which allows you to run things you would normally run via PuTTY directly inside of your LabVIEW code. Now, the limitation you have is if you use the System Exec VI inside of your LabVIEW, it runs as the user that is actually the compact radio, which at that point is a user called LV user. It's not an admin, it's not anything. It doesn't have a password. It'll ask you for a password if it doesn't have one. Or if it does have one, you don't know what it is. You can't get it. So a way around this is you need to change the LV user to be in sudo as part of the sudo file, which is a simple command you just do via PuTTY, and it allows the LV user to have access to certain commands. I should present that. You can add it to have commands over everything, which can be dangerous. I personally use it and I'll explain in a couple of slides which ones I give it access to in particular. This step is important because for everything else I'm going to show you, you have to have done this first, or else nothing else is going to work. You're just going to get file not found. So the first one is connecting to network drives. Now, technically, it's kind of half supported. NI's website has a KD about how to connect Linux-based compact radios to network drives. It doesn't, well, I think it kind of half works, half doesn't work. It works fine if you have something like this setup here where you're in control of storage as well, and you can adjust things on the storage as in what level of security it's running, whether it's a Windows share or a Linux share, for example, how it displays itself, that works. The biggest downside of the KB and also the default way you connect to this is you need to boot the compact radio and then connect via PuTTY, write a command as admin to connect to the network drive after the compact radio is booted. And then the biggest downside is, when you reboot the target, it loses that connection off to that drive. Using the default instructions from NI, there's no way to make it persistent. So at this point, you have two options. You can either change the Linux file system on the controller itself by changing some files to have it always mount that network drive every time it boots up, is option one. Or you can make use of this System Exec VI that I mentioned before, and actually programmatically connect to your network drive. Now, I personally always use this programmatic connection, because it means on a test rig where you hit the power button, remember I said before, as long as the compact radio comes on first for everything else, one of the last things to come online is network attached storage, which means if you have it the other way around, the compact radio boots up, can't find the network attached storage, errors out, and never tries again. If you do it programmatically, you can wait until the test rig's actually booted, and then you can do connect the network drive, and it will connect at that point. You can also programmatically reconnect if you've been disconnected. Or if IT changed the place where the network drive was from file share 1 to file share 2 for some reason, you don't have to go and change the base level of Linux. You can actually at that point then just change the string command you have here and then have connection back off the network drive. You do need a couple of extra helpers that you can install via PuTTY, but they will allow you to connect to pretty much everything, including the full Windows 8 groups. So we can actually use them to connect to our Windows 8 server and have operators automatically log in, using fingerprint recognition as well straight into the AD accounts now. So it's a huge benefit. Next one is remote desktop. And yeah, I will try and give you a demo. It's not going to work for the virtual machine. Remote desktop is available to you on the compact radio installer. It uses the DNC client, and effectively what you do is you open a connection to the compact radio, you get full control over that user interface at that time. So as that screen appears there, you get control from any other remote device. Biggest advantage would be if you've got it set up, like we quite often have them set up with a touchscreen interface. It's not the most intuitive. It's fine for running the rig, but for lower level functions, there's no keyboard, there's no mouse, it's not very good. You can actually just remote desktop into it, use your own keyboard and mouse from your side, and have complete control over that actual system at that point. So a huge advantage to move Windows around. And then unlike Windows remote desktop, it logs in as the user is currently on that system at the time. So you can run the rig from your own machine. So when we're building up test rigs, we can actually use the remote desktop connection during development, testing, before we've gone to the effort of procuring a touchscreen monitor or attaching it onto the actual rig at that point. You can use the remote desktop connection. A couple of caveats to this though. I highly recommend adding a password, as I accidentally shut down someone else's Dyson's test rig because they hadn't got a password on it. I just scanned through, found one, connected to it, had the regular LabVIEW screen, I rebooted it, and I realised that the screen that was connected to my computer didn't reboot, so I shut down someone else's test rig. More fool them for not having the password. So, now we have a password, so that's going to solve that problem. And then the second thing that I would recommend is, personally, we've got for the rest of our team, is we don't use the remote desktop connection unless you can physically see the rig from where you are at that time. The reason being is you see that rig we had earlier with all the moving parts in it. There's two situations could occur. The operator could have overridden the interlocks because they've set up the test, and you could then force the test rig to start working with them in it because they've overridden the interlocks. Or you could also affect the test rig running. If we're doing some performance test, you could remote input change it. So we've changed those so you have to be physically connected to that rig. It doesn't work over the actual Dyson network at that point. That's a recommendation. The last one is a web browser. So this one here actually does have Firefox installed on it. You might think it's a bit overkill by using a web browser. The reason we've got it is Firefox supports things like opening a PDF. So if you have a manual for the actual test rig to run at the time, you can just double click on the PDF and it will open up in the Firefox browser. Not to mention we have a lot of online web solutions as well. So the shifts that technicians all operate are all based online. So having the web browser just means that we can get X my current shift and it will jump them straight to the page with the Windows AD login. They don't have to have a separate computer or anything else. It's all along directly on the actual test rig itself. So I've got that installed. That's probably one of the harder ones to get. It's the hardest one that I've got working on here. I have another one that I tried and I ended up clicking a compact reel. We'll cover that in a minute. But this is a very good way of making open up web report, for example, as well. You can have a web browser built straight in, and it's, in case anybody's not believing me, if hopefully, I've said this now, that's not going to work. Whoa. Down here. And just as a caveat, it's a really old version of Firefox. Okay, so I am working at trying to get a more slimline version, but that has indeed opened up Firefox with a couple of glitches for the last web pages that we're on. But I am trying to get a more robust version of this up and running. I did try Chrome for a little while and I couldn't get it to be stable on the actual system. And I know there's some other lighter weight Linux ones that probably should fit, but Firefox is just an easy workaround for it. So you can get hold of it.
So what's the barrier to that? Is it other libraries that need to be installed?
Dependencies is the main problem, yeah. So unlike if you use something like Ubuntu and you try and install something, it's quite helpful. It tells you this is missing, would you like to download it? On this system, it won't tell you what's missing until you try and run it, and then trying to find those independent ones. Even trying sudo and stuff, don't worry. It can't find those individual ones. So that's the biggest blocker I've had so far, is trying to find something that will reliably work without getting to the point of having to flash the compact reel because you've done something you shouldn't have done and now it's not moving correctly. You can push it to a limit and it will eventually just break and not turn back on again at that point. Which is a nice segue onto my next section here. Which is, I had a bit of a problem. I had a 9030 and I was messing around. I was trying to install Docker. Docker, so we did virtualize Linux hardware. So I managed to install Ubuntu 14 onto compact reel. I say managed. It worked for about 30 seconds. And then it absolutely bricked itself. And by that I mean all four lights in the front, like the FPJ, LED, everything just permanently on. Nothing, no lights are on, nobody's involved, like absolutely nothing happening. No console out, nothing, like completely dead. Considering these units cost, I think the 9040 is about £2.5 grand. It's not a small mistake to make, the fact that it's completely knackered. But luckily I used to work at NI, and I know that there is a secret recovery USB flash drive that exists for this exact situation. So what I did first of all though is, then there's ever completely bricked PXI before, you can make recovery media from NI Max. So I thought, well, I'll go to NI Max and I'll see if I can get recovery media with stuff. And to my surprise, they've added an extra menu in 2018, they added an extra menu, which is the Create NI Linux RT Recovery USB drive. So happy days, I'll just boot it from that. Turns out it's only for PXI, but this is actually a situation where the limitation of our IT department was actually a major benefit. Because I can't just plug in a flash drive to my computer and flash it with any old software we've got here. So while I was waiting for IT to approve my request for a flash drive that I can put the software on, if you open up that window, there's a button that says Browse, and it takes you to this hidden folder, which you can't really see here, and inside the hidden folder contains an ISO file for Linux real-time. So I reached out to a couple of people at NI and I said, can you virtualize these things? I was on a couple of forums and loads of requests for it. Even on the Ideas Exchange, it was the top thing at the time on the Linux RT Ideas Exchange. Can you virtualize? Nobody had done it. And I thought, well, I've got a couple of days. Let's have a go. So after a colossal amount of messing around with it, I've done it. I've virtualized the entire compact radio, and I'll show you now. So not only, okay, we're going to have to shut this one down. Okay. See, I'll be honest, I've just got an extra button on the top. And then, 2 seconds. So with a bit of luck, this is one limitation because it's not officially supported. You always have to do this one. Here we go. That is a fully working virtualized version of the same system we have on the compact radio here, directly running natively on my computer. Okay, so I've got both the Windows and the Linux system working side by side. Now, not only that, you can target this from NI Max, you can install software on it because it comes with the default version, and you can target it inside a project. So you can literally run anything that you would normally run through a regular project like this. Full setup I have here for development testing can actually be done just natively on my own computer now at this point. You don't have to have the 2 different sets. And I will attempt that now, but precursory, so I want you to connect to the actual real hardware, so I don't make any promises. So this was a big limitation that again has used for this, trying to get 2 virtual machines to speak to each other on the same computer. It's not great fun, I'll be honest. Well,
We have on the Windows version of VMware, has quite good success. You can configure, if you stick them on NAT, they're normally on their own local network.
yeah, so if you configure these two, the network private to only this host, except for the Mac should then be the main thing, but I think it's more of an NI slight thing. So, if my Windows machine is actually, here we go. So I'll leave that one up there, and then just so you can see that's what that actually is. And I'll connect the Windows machine here. All of the change that IP address in my project. Where we just now so you can see. I changed the IP address in my project to match the local virtual machine, which I'm hoping is just going to work. Which is again, this is something we have to find out in this DS and the public command, or it's actually stored inside the compact root. It's a text file on the Linux compact root that contains all that addresses. So you want to properly brute force this, you can just modify that text file to change the IP addresses. And your MAC address, which is kind of a bit alarming, you can change it to whatever you like, which has been quite helpful for us recently. Systems don't allow the network of the MAC address to prove, so I was able to make all the compact root the same MAC address and then they're all MAC address. Okay, so if I put this back to extend desktops, right, so now you can just see just my virtual machine now. If I open up the simple admin project now, and I click run, well, straight on the virtual machine on the same hardware we've got here. It's definitely not on this compact rail, and just as full proof. Unplugged it, still works exactly the same as what you would expect. You can test those UI elements between Windows and on compact rail directly from here. So any change to make on this side, then happy to regular on other sites as well. So full development testing for that.
Is that what you generally use for that rail? Compact rail system? I did it actually real one. So you might be iPad.
UI development, but I've got a few use cases actually. What we use it for. So I'll show you. I'm just going to shut down one of the virtual machines. As much as I enjoy having a mobile phone Mac, it's not quite. You can see this is all I've done with the cable is on 44% battery, so. I'm just going to shut it down. So yeah, a couple of use cases for that, why we use it. Things like driver and functionality testing. So we write a lot of drivers in-house for all of our pieces of equipment. We have to connect multiple things. Some of them are internal drivers just to connect the actual products themselves. They have their own communication protocol inside. And some of them are things like universal robots, collaborative robots. There isn't a library driver for them. We've had to write one from the ground up. And the reason we use the virtual machine test is does it actually operate on the virtual machine on Linux RT as well as operating on the actual computer itself. It rules out things that you saw there, like trying to connect to physical hardware, how you have a set of screen, all this stuff. It can develop and test on desk. Also, some drivers don't work on Linux RT if they've got a DL element, for example, like some of the drivers like TTI, benchtop instruments, are all CPLL-based drivers. You can't use them natively. You have to convert the commands if you want to use them. So that's a good way we test it. And you'll see if it can't deploy, the replicable target as well from there. Another one is UI development, one of the big ones we alluded to here. This is actually two screenshots of exactly the same UI, one running under Windows, and then we doing that trick where you right-click, run it on real time, both hit and run. As you can see, they're quite different from each other. So the yellow bars you see here are actually split panes. So I've tried very hard to try and minimize where this problem is coming from. But the fonts, text styles, everything do adjust when you move from one target to the other. You do have to make changes to that. It usually gets bigger when it goes to the next site. I have tried installing the same font on both targets to see if that works. It doesn't make any difference. It still gets bigger when it goes from one side to the other. As far as I'm aware, there's no real way around this at the moment. You just have to experiment with the UI and how you expect. Using the splitter bars, you could force it to go to the extreme edges of the splitters, and then that works. It dynamically resizes. But it means that your text ends up fit properly in the box. You can't dynamically resize the text. So it is a limitation from some of these user interfaces. Okay, so that's everything I wanted to show you. Thanks very much for listening. And if anybody has any other additional questions, now's the time.
What was the pseudo for LabVIEW using the plan?
What was the, how did you do it, or what was Oh, how do you actually do it? You just add it to a single line. I've got them all documented. I'll find a way to get them to somebody. I don't have a blog, but I'll find a way to get them to somebody. It's a single line. It's a file inside of Linux that controls all pseudos. You basically, the reason that I did it specifically was I limited it to only have access to the mount command. So I added it to have ability to bin mount, so that it only can access the network drives. I tried to do anything else with sudo, like, for example, change it to a MAC address. It would just fail at that point. So you can make it have access to literally every inside folder, but then that's a bit sketch. So I've limited its access. It's like changing file permissions to 777. It's never a good idea. Anybody else?
So just out of interest, would be feasible to virtualize other aspects of compact video hardware? Is that something you've looked into?
So I'm currently testing DAC and X on the virtual machine because the new virtual machine shows up as a 940. So in theory, it should work. We haven't had time to test it fully, but that should work. Obviously, it's not deterministic because it's running on the rest of it, and there's no FPGA, right?
Because there's like a module.
You can simulate, and that does work. You can add the chassis, and you can't interface the modules because it needs the background of the actual compound wheel. But you can simulate all the modules like you do if you didn't have the modules using regular compound wheel. As far as MLUG is concerned, it's a proper full compound wheel. So you can even add the FPGA, try and write an FPGA VI, and get a horrific error message you've seen before, and it just crashes everything. Like to the point where you have to reboot the computer, not even you can't just reopen MLUG, it's like a complete reboot of the computer, and it crashes everything. So that's why it's not officially supported. Cool. Okay.
Right, whilst Neil's getting on to the technical stuff, and
How many weeks did it take you to get that reputation past security?
It was a good process for that. It took me about 25 minutes because then we began. It's not about what it's about who you know. Just put that on the ground just now and then switch back up.
Alright, so I was, at the last blog I did a similar thing to what I'm going to do today, but we didn't kind of get through everything that I wanted to get through. We kind of covered a few of the topics. So just to recap for you guys who weren't there. So what I wanted to try and do is just to understand a little bit more about how people successfully complete projects. So everybody, we complete projects, I'm sure everybody here does that. And just try to understand a little bit more about how people do it successfully so that we can kind of learn from each other really. So before I jump into it though, I thought I'd take this opportunity just to do a bit of promotion for GDevCon. Who's heard of GDevCon? Pretty much everybody, this is good, we're doing our job almost. So that's a little bit about what it is, and if you're interested, we've got all the videos from the last two conferences are up on our YouTube channel, they're free, anybody can access them, so I'd recommend you go and check those out and see what's up there. There's some really good content over the last couple of years. This year's conference, I'm going to put a date on there, it's the 8th and 9th of September, isn't it? Yeah, 8th and 9th of September. I'm heading over to CERN in Geneva, so branching out into Europe, which is cool, very excited about that. And the call for presenters and sponsorship also are open at the moment, so just jump on the website gdevcon.com and go and check it out. Right. So, oops. Right. So, like I was saying, everybody completes projects, and sometimes they go well, sometimes they don't go well. I think everybody's had a project that hasn't gone well, and they probably have a few reasons why that's happened. And really, what I want to try and do is just to understand that a little better, and maybe try and pull that information together so that we can somehow share it, maybe locally within our team at Argentina, but also with the rest of the community as well. So like I said, I started doing this at the last user group meeting. This is kind of what I sort of broke down the elements of the project into those sort of 7 topics. And like I say, we covered the first 3 in the last user group, and just a quick summary of where we got to with that really. So design was the biggest part of the discussion, as you can probably imagine, because it's probably where a lot of the stuff goes on really. So the first topic we covered was about sort of scoping and requirements capturing. We talked about quite a few techniques that people use for that. Some people use block diagrams. So this is basically sort of setting out your system in blocks and sort of seeing how they connect up. Also sort of UML state diagrams, so looking at how different bits of your code might transition to one another. User stories were pretty popular, like a lot of people had used them. So this is the concept of sort of defining requirements through stories. So it's sort of more of a human readable way of defining requirements rather than sort of being technical, I guess. And other people are using kind of workshop sessions as well, so getting sort of projects in together, discussing things, and trying to sort of work it out through sort of longer discussions like that. And then we sort of talked a little bit about tools that might support that. Requirements gateway we mentioned, not so popular, not many people using that. Excel was probably the one that came up as being the most commonly used. And then Jira was one that was more of a sort of comprehensive set of tools that give you a bit more than just sort of requirements capture. There's quite a lot to that, but some people are using that. And then we talked a little about sign-off, like how you manage sign-off of your design. So some people are using sort of a document to sort of highlight the high-level functionality of your system and using that to sort of sign off with the customer to commit to something. Some people are using the purchase order as sign-off. And then there were other sort of more formal ways of doing it by having sort of gates in place to during that process to make sure that it's captured. So sort of varying degree of things going on. And then reviews really was another topic we covered. So most people were doing code reviews. Some people were in sort of sole developer teams, some people in sort of bigger teams. Some people doing it informally, some people doing it more formally. And the other thing that came out of that was people also do functional reviews, so not just code related stuff, but related to other sort of aspects of the design aspects of the system. And then we sort of covered risk, and this wasn't, we didn't really talk about this too much, so I want to try and sort of discuss that a little bit today. But the sort of two main things that really came out of that were sort of risk prejudices, so a relatively simple way of identifying probability and severity, and then having a sort of calculation off the back of that. And then a more sort of detailed approach was the failure mode effect analysis approach. And then the last bit was talking about sort of development and how people manage that. And specifically really looking at how we talked quite a bit about managing sort of time and how you assess where you are within a task. So people sort of used a few different tools for that. Redmine was something that somebody picked up as being something that was quite good. And Jira's also got some functionality in there. I quite like the Jira one because it's kind of like a stopwatch, so you can sort of start it when you start your task and then stop it when you've finished it, and it's sort of automatically tracks your time, which was quite neat. And a quite interesting thing that came up also was this principle of the automated testing triangle. So I'd never heard of that before, so I had a little quick look up at that between last meeting and now. And I've got a link on there which we'll share today as well. So it's a pretty good article of that and sort of explains what it's all about really. I'll click on that. So this is the testing triangle that you can't do very well. It's basically, it breaks down different types of tests. The idea is that you get your manual testing section as small as possible because that basically improves your maintainability. Because if you need to make changes and then validate your changes, you haven't got a ton of manual testing you've got to go through. A lot of it is automated. And I appreciate this isn't always possible depending on what you're doing, right? But that's the sort of concept to sort of maintain, or sort of keeping maintainable code. So I thought that was quite interesting. Okay, so now I'm going to open it up, so hopefully people will be willing to speak and give me some feedback, otherwise it could be quite a short presentation. So coming back to what I was talking about, was the topic we didn't really cover a little bit, but we didn't go into too much detail, and that was like risk. So we talk about risk within projects. I mean, a real critical one for stuff that we work on, because we're typically interacting with hardware, so that's always going to be a risk, and interacting with test rigs or whatever it might be. You're not going to get to that point until quite a way down the line, so there's obviously going to be some element of risk associated with that. And generally with software projects, I mean, they're probably relatively risky, and there's ways of sort of handling it. So has anybody got any really, really great approaches, got a silver bullet at how they manage risk within software projects and would want to share that with us? I think you've obviously got quite a few people that need to be sort of informed about this, right? Because once you start a project, you need to be able to sort of communicate this to sort of everybody that's involved in it, making sure that people aren't expecting stuff when at some point when actually that you're not going to start doing that because you need to focus on the more riskier things first, which is typically how most people would approach it, right? So you sort of bring those risky things right to the front. And if you've got hard, I think this virtual machine thing is pretty cool because you can really start to bring those quite risky things forward if you've got to try and set things up. And if you can do that via a virtual machine, that's quite a nice way of handling some of that stuff.
So I think in terms of risk, as the customer sees it from a software development perspective, their perception of that risk tends to be things being delivered on time and things working correctly. From a hardware standpoint, a lot of that can be mitigated, I think, with risk assessments and having to prove your hardware does actually meet certain standards. But in terms of delivering software, the one that comes up again and again is really delivered, that sort of thing.
Yeah. So have you had any experience of managing that, and what sort of techniques have you used? Or?
Oh, I barely manage. I think, constant communication, keeping people in the loop, showing people the progress that's being made. It has to start with a reasonable deadline and specification.
So just to summarise that, the risk is that you estimate that this project's going to be delivered in 5 weeks, and the risk is that actually that's not going to happen. And that's the perception of the customers. They've got a perception that it's going to be 5 weeks, and then as you go through the project, that can change. Things can take longer than you expect, and it's sort of how you manage the customer, I guess, in that environment to make sure that as soon as stuff starts to slip, you're sort of communicating that as soon as it's happening. And one of the ways you're talking about is that you sort of incrementally try and share. If you can, I think one way I've never really got it right when it managed to get it to work properly is to sort of take the functionality and show that this bit of functionality working. That's sometimes quite difficult, I think. But I don't know if anybody's had any positive experiences of that. Do you know what I mean? So if you've got an overall system and you're working on like this, a section of it, taking that section of it to the customer and saying, oh, this is this bit complete now, so you're sort of giving them some confidence that things are progressing.
I think leaning into both what you said there, so obviously just for the highest risk areas, how long it's going to take. So it's going to be how many, start to finish, how long will they have their system. But to you, that high risk area will be, I don't know, so you can identify at the start. So like, say you have an algorithm that's really complex, but you need a way to prove to them that that's going to take some sort of time. So something we're doing recently, I appreciate it's quite niche, and we're redesigning something that has an algorithm at the beginning, but also in the middle. So what we've done is been able to take that and redo just the algorithm part and then show that, and then you've basically mitigated the risk of the part that you think can take the least time and say, this is how long that will take, therefore I can build mine around it. So high risk areas are something like algorithms, distribution often. So when I say distribution, we might get data somewhere to a database, things like that. So being able to kind of address those early doors and kind of show that they're working or this is how it would work, we can then mitigate that risk or make that risk less risky.
Because I think along with the traditional economic distribution stuff, there's probably other people involved in that. So potentially like a third party or maybe a database that somebody else owns or like an API you need to communicate with. Like it's critical to identify those types of things and then go out in front and then really approaching those people that are in control of those to make sure that they're aware of what you're trying to do and any access that you need or anything like that can be sort of ironed out right at the start.
And one additional thing that we do as well, so what we do is try and use a standard set of hardware to be standardized on all, like a compact reader 90 for example, and 40 overkill for quite a lot of applications. But the fact that we use one type, we always keep one additional one in stock. So if a compact reader goes down for reason in test, we use hotspots with a new one using the RAD utility to bring it up to speed. Then investigate why our other one is stopped working. So we get no downtime on that. It's good for test development, but we write drivers. We spend a bit of extra money on trying to standardize all hardware, so all PC drives, AC sources, everything up front. So we list things down massively. If someone says you're testing for XYZ, we're confident that those individual modules all work.
That RAD utility is really good actually. It's a really good way to manage you know, images of contact radio.
For us, we have to identical units for claims, one in Singapore, one in the UK, even though the other options are called one
Yeah.
to make sure the other one performs exactly the same way as you expect.
Yeah.
I think our IT department have a hard time. I want to have some way to see if we also have well talk to each other. So, no, but no, we don't use it. Right.
So how do you manage your images then to make sure that you know, like, I guess it's version control in a way, isn't it, to make sure that you know what's on what? Is that through a system or a...
We use Git, so we use Git bucket to maintain repositories and only set people that are related to generally valid images. Then a complete review of the UK version. We take an image and it's working, and then we do development work. And then when we're happy with development, it's sent on URL 6. Technology ready 6 will then take a clone of that and deploy it to that one Malaysia. It's waiting for us UK development in Malaysia. Bash the next one after the that's what's that's great opportunity.
So that's management of a risk there, isn't it? The risk is you have different versions of code on different contact radio, which should be a nightmare. Yeah. Yeah.
By HP here, but Malaysia might be or Dell or something else.
Yeah. So yeah, your transfer over to pure Linux is another example. Yeah.
We know I know that radio is identical.
Linux is Linux.
And the software money is exactly the same software money. There's no variation.
So I think we've kind of talked a little bit about how you upfront manage risk through risk registers or FMEA or whatever sort of approach you might take. But I guess one of the big things is what you do actually when one of these risks comes up. So how do you approach managing it with people? How do you approach getting it sorted? Like there's probably, I don't know, there's probably not really an approach you take, you just kind of react and do stuff. So there's probably a couple of things in there you probably need to think about. I think communication is a massive one, which you picked up on. Like, you just need to communicate it as soon as it happens, as soon as you know about it. And then it's much easier to then get it resolved. Like it's a nightmare if you hide it for a couple of weeks thinking you're going to solve it, and then you have to try and explain to somebody that something's gone wrong, and then it's a couple of weeks down the line, and actually somebody could have helped you with that. So anyone got any experience with that, when it's gone well or when it's gone bad that you've learned from? Everyone's doing all right.
Just communication. Just keep coming back to that. Just talk to people, let them know what's going on.
Yeah.
Yeah, I had one project that led really late, which was just down to hardware issues. I mean, quite fancy, just owning the issues I found with customers. Appreciate that. Don't go to them and say, this is a problem. Go, right, this problem is what I'm going to do. You know, it's what I need to do. Yeah, not everybody does that.
Yeah, so if you can go to them, not just saying, oh, this is the problem, you go to them and say, well, this is the problem, but there's a few things that we can do to sort it out, and kind of give you some steer on where you want to go, and they can sort of start and input from that. Yeah, I think that's a good one, responsibility, with taking ownership of it and really driving it through. Yeah. Any other comments on this? Any other thoughts?
I can give you a bit more of a manufacturing viewpoint on when identify risk becomes reality. So we have to work with FMEAs and CFMEAs because there's lots of investments in tooling and so on. When you report on these projects, we've got a fairly regimented process for whole design through to the first stage of production. We have a call, so there's a lot of forced project communication for our sign-offs in this regimented process. And one of the things you have to do is raise risks and make sure they're identified as soon as possible. They can become this concern, at which point they could affect the timeline when you start to react and map out worst and best cases to these. And that's how you handle it. So your stakeholders are all aware quite early on. If you've got 3 or 4 concerns on the project, that could be quite, depending on the scale of the project, that could be quite bad. And you don't quantify that in terms of money and in terms of time. It's all very high level project management stuff, but the value, this is not just software, so the value is in real assets and tools that might have to be done at 10 to 20, 100 £100,000. So, but it's a different. The process forces us to identify risks early and then bottom them out before they might even occur, and you've got a plan if it does happen. So the FMEA will say, if you mitigate the risks as much as you can at design stage, and then you test for anything that you can't design out, so you already have a fairly good idea of what could happen.
I think that's a good point about quantifying the risk. Like, if you can go to somebody and say, we've got this risk. It might not be a massive risk. You might say, this is going to cost 300 quid to sort out, or we carry on like this. They might say, well, 300 quid's all right, I'll accept that, and I'll go down that route rather than ignoring it. And I think that's quite a good point. So the next bit, which we didn't sort of cover last time, was around management. So project management was just sort of briefly touched on it there. Thanks for the link there. So how do you tend to manage projects? So are there any particular tools that you found useful in managing projects? I think we've talked about a few, like Jira probably has some capabilities in project management-ish. And I think the first question is quite an important one, which we've kind of come across a little bit. Is it an independent role? So should it be someone that's not actually technically involved with the project, not a software person, if possible? I think for us, it's really, really important to have somebody who's got technical knowledge, because non-technical project managers typically, in my experience, they've got a lot of experience managing projects, but they don't understand the technical aspects of stuff, or at least even like 50% of it or a little bit of it. They really struggle to engage with the project team, and then that can cause problems. So I would say on the top question from my experience, it probably is that the person doing the project management needs to have some sort of technical capability. I think it's also good for them not to be involved in the development of the project, so maybe not one of the guys delivering the project. That's not always easy, obviously, depending on the project size, team size, and all that kind of stuff. Anyone got any experience in that? Sort of project managers that aren't technical,
Having someone away from development, obviously, it's difficult for me. I've had experiences where it is there and it's helped. I think to have that overview. Because you can also have the other side, someone here's going, everything's going badly, everything's great, we're well.
Someone who's not like invested in delivery as such, their role really is to make sure it goes on time. That's their driver. The guys who are technically doing stuff, their driver is getting the software developed. Whereas if you've got somebody who's purely focused on
because it is a step that I find it hard to switch when I'm doing the development. It's very hard to get out of development mode and go, hang on, right, let's step back and let's look at the big picture again and who else is involved.
I think you're also looking at that area of someone in project management. I've had it a few times where we'll just fix that software. Like we can buy this thing that costs £30 to include it. Like, I know we'll just make a customized and do that exact thing. Like, it still takes, it costs usually nothing up front, but it's weeks of development. So we're similar to guys in project management or category specific roles. Like some do like 5 categories in Canada. But they're not necessarily one for it. They might be one for it that work depending on what it is, but they're the ones that run through all of the projects and we call it from other things. So they do everything in the pipeline. We call it other things depending on their expertise. Maybe it's really depends on complex
that's a really good example actually that we've come across as well. That people tend to think that software is easy and quick, relative to other. And that can get you into trouble. And trying to have that conversation as well. It's a difficult thing to try and get across on site as well. I think that you've got nothing really to use. I find it hard to find things that you can use to explain that you're not free. It's can be a difficult conversation to have. Let me come back to communication a bit. I think that's probably key to any management of any project is communication. And I think you can do too much of that. Like daily project reviews or whatever, but I think weekly is probably a pretty good frequency on, and I guess it depends on the size of the project, right? If it's kind of a month-long project, then maybe weekly reviews still apply there, I think, but it depends really. Anyone have any experience with good communication, bad communication?
Got a bad example. Well, where I think the weekly review would be a problem. My project in a minute is my customer, me, and then the parallel team work with some aspects. And they have a very strong tendency to, because we have a weekly call scheduled every Wednesday morning, you'll get to the call and they'll say, oh yeah, we hit the call on Friday, so we've asked you about it. So why didn't you? People will back things up until the scheduled call instead of just dealing with it then. I think there's a bit of a risk with that approach. I think you need to keep people up to date weekly on where things are, whether that is the call or something else. I'm more inclined to pushing out a status update and having a call with the relevant people.
Yeah. So how would you avoid that happening? How would you get them to, on that Friday, get in touch rather than hold on to the Wednesday? Do you think it's purely the fact that there's a weekly review in there, or?
I think instead you made it everyone sends an update on Wednesday morning on progress. Instead of having an organised call for a decent time, I think that would be more of an impetus to call, get the phone there, and so we get the phone calls. And that's a very personality thing as well. Some people wouldn't do that either. It depends on the team. But that's been uniquely frustrating. And surprisingly, it's very frustrating. Just great.
There's another way possibly around that is actually shorter but more frequent meetings. Meetings are normally, it's really hard to be effective in meetings, especially you need to question whether you need to be there. But one thing that works for us as we get closer to production launch is we have daily stand-up meetings, which can be 5 minutes, but APS up to half an hour, normally 15 minutes is one meeting. But you generally only go if you've got something to say or you need to hit something, and that means that you don't wait for the next big meeting once a week. But it's a balance, because if it's optional, it's a very
Do you think there's any tools that can support that? Because there's stuff like Slack, isn't there? Things like that. Slack, do you use Slack?
I've used it as well. Mainly for unit designers, we came out and it's a really good project for people working all over the place. You just jump in Slack, see where everyone is. If you pick up the Slack, then you can really help people.
I guess in that example, if someone on that Friday had the opportunity to just easily dump the question in Slack, and at least that gives you the opportunity to pick it up and say, right, let's give this guy a call and just catch up on it.
So just to experiment with that, are we just describing agile software development? Really? The idea of scrums and standing up and what's going to happen.
Definitely. And I think in a software team, like James' example, you've got sort of 3 entities. That's probably a little bit more difficult to have a stand-up when the 3 people are in different parts of the UK. That's what a Slack, but you're right, so the Slack becomes like the stand-up effectively, but it would be 24 hours. So James, you get one or 2 o'clock.
It's also helpful to position everyone into different schedules in this case. But I think if you were all, even if you were distributed but within a company and that project was a full-time thing, I think you can still do that remotely. I've heard people doing that with Zoom or something. You hop on a call, exactly as you described. So I don't think I think the power project actually can manage well in terms of agile. It's a word I've heard querying around a lot. Guys saying they just got rid of the desks and said everyone was agile now.
Hot desks.
But I found that open communication channels, especially internally within companies, can make managing projects somewhat more challenging, because that constant availability leads to less formalised specification, and therefore people will be more likely to ask for changes. I mean, changes are going to happen, but they're going to be less thought through, and you're going to have to constantly have this dialogue if there's not a formalised way of sitting down and having a communication channel.
If something gets involved in email, someone asks them to change, but that one source of development to change, they make that change, don't realize they're not on Excel. So we started from Microsoft Teams, basically the Microsoft group version of Slack. So again, going back to that, it's not chat, it's Slack installed. Microsoft Teams is basic, and you can also do things like you can now direct users or zero responsibilities as well. If someone has a question or something, they can just push it straight in, go in the team for everybody else to see, and then we can all make changes from. And then we also follow the TRL process as well. In that, technology readiness levels, we start following. They're kind of uniform from diocese and the Creole I talked about earlier. But there's some we start adopting now when it comes to communication and time scale, etc. The TRL rules can only be the little equivalent standard, they're only allowed to be 10 minutes long. And you have your stakeholders all in the room with them at that time to discuss what the person is, and in the event that it's deemed that you're not at that level or that state, you get knocked back down to state at that time, and all stakeholders are updated. The project is now being released to still derive because it's not ready or where it should be at this point. And so it's a new way to start doing it. It makes it a lot easier to get the exact point. If you want to, you don't have to meet, you should agree that they're all process. So we haven't said if someone would email and say I can't do it, they just assume that they are happy that they're on the documents and send out in advance. So if someone's not happy with it, they'll come and see you. So you don't have to chase people. They're not there, you assume they agree.
So the TRL, does that just apply to products, or does that apply to rigs and any projects you do, or is that?
For us, it could be for the main ones we deal with are test methods, which are one. So test method is something like how to actually perform a particular test. Like for a vacuum cleaner, the test method will be it must move forward at this speed for this amount of time, and the humidity must be this, all those kind of parameters are actually performing the test. So it's not with one set. And then the second setting for the actual full test rig will have a separate child TRL processes. And then we have different readiness levels for that. So when it gets to TRL 3, we've got a prototype of some description of the rig. It's not quite there yet. And we're trying to get to TRL 6, which should be fully functional and able to TRL 6 is the right way. That's not one we're on. It's supposed to be there. I haven't made it yet. TRL 6 is where I got one, but TRL 6 should have the right number, name on it, any problems. It's a new process to start adopting. It's all documented and logged through Jira. So when there's a problem with regular specification changes, you can knock it back to your stage data.
You found that quite working well?
It's working very well for us now. Actually, it's a big blocker of systems to get work done. You lost the flexibility. Or sometimes you need that flexibility to say, oh, actually, instead of being 44 mil, it's 8 mil, and you just change it. You lose a lot of that to through this process. But now we have official reviews. We don't get to the end of the project. Actually, we're 6 months delayed, and this entire way through, we've known for the last 3 months that we're going to be 6 months delayed. So nobody brought it down to attention. Stage 18 is very fixed once you pass the stage. But then you can also get you could be a TRL 7 and not all the way back to TRL 1. With the spec changes or the product changes, you can go all the way back to your first stage. There's nothing to do with that. It's not like you pass it and that's it. You have to maintain that for us to find. It's quite I think it's quite nasty to use the TRL process. There's some good videos online, relatively simple to set up.
It comes from R&D, I think, like the Innovate UK.
Yeah, they
TRL.
Because we've got the predefined consistency of the
Yeah.
Yeah.
Yeah, that's quite ready.
Yeah, exactly. I think we've got 0 on 9. That'd be quicker. You just do some more.
I think we've touched on managing timescales, I guess. How do people manage when things are going to slip or so if you've got a project that you've sort of committed to, which is 5 weeks, and you know it's going to take longer, I think it all comes back to communication. There's much more to discuss on that, really, is there? It's not.
I guess keeping an eye on it, that's where I use Jira.
Yeah.
So don't do it well enough. In theory, I look every week at
Yeah.
how much time I think things left and how much time I've got left in the calendar.
Yeah. So monitoring is
having some way of tracking that progress as you go. You can see that.
Yeah.
what I gather, people that use it, people swear by Atlassian platform, so like Jira, Confluence, and I've got a house-based software, and they're doing like large-scale loading projects. And what I'm seeing it used properly, and how you can integrate a bit more capability, it kind of puts into perspective, perhaps. Go back to what you said, you use Jira, but you use Microsoft Teams, and which that's Atlassian product.
Did I hit chat?
Sorry?
Chat.
Yeah, so something like that.
Well, yeah, they have to do with paragraph next classes, runs on premises, and it's like, it's like Atlassian forward, like when I say small, it's like all this is what we're going to. So yeah, it is quite good, particularly in Jira, you link back to slash, you can do this branch, it's just a visual code link back to things. That's what
it just seems like that in itself would be a sort of topic, like how effective to use Jira, which I'm sure you'll know just about that, but like going back to how you go through your project management, so you go from, it doesn't really support, I haven't seen much in terms of like Gantt chart and specifics, so some like smart sheets you could do as a Gantt chart, and you could then take your requirements and how you actually translate that into those tasks and subtasks and what they call it, epics or not. It's just kind of that in itself is I think the first crucial part of how you actually manage a project. Because if you've got to use a one-minute task, lots of tasks, then it's not really going to cut it. And also go back to timing as well. If you give some time, how much it takes, some story points, whatever you want to call it, you can then track that, and other people can track that. And that kind of lends itself quite nicely to the management part of the process. So it takes away from that strictly about documentation, then there's agile, not the same. Spectrum, isn't it? Agile, it's quite an interesting point. People seem to use it and just go, that's the one forever.
Yeah, because the Microsoft project gives you a good visual, isn't it? But it's just a pain in the arse to maintain, linking everything else. Yeah, so I think that visual is good. It's just trying to work out a tool that kind of makes it.
I spent ages trying to get the big view out of Jira, and I just couldn't get anything out of that. I couldn't do both. I think something like Jira is great for day to day, but you still need, like I said, smart sheets or projects or something on top that, you know, maybe once a week you look at Jira, you go, okay, we'll update the big view, and we can understand where you are. I think the two, ideally, use them tandem, because Jira is too in the weeds. You're going, well, I've got this issue, I've got this issue. No, I don't care. Are we behind?
You can make it to the tools that we Microsoft, I want to call it Microsoft Planner, I think. You can actually link Jira Direct, Jira Teams, and Microsoft Planner. Microsoft Planner gives you a Gantt chart, but it actually pulls from Microsoft Teams and integrates with Microsoft Project. There's an extra tool Microsoft has called Planner, and it actually sits in between. It's part of Microsoft Flow. Come across that before? Actually synchronize. And you can integrate it with Microsoft to do Microsoft to do tracking all like projects you have open, what tasks you have open, who you allocate tasks on to, and if everybody's on Office 365 in an organization, you can file it directly off to them, and then they'll get synchronized together who has this task, when it's due, and it updates to you, etc. automatically. I say
I've always heard with stuff that automatically bridges that gap, there's a little bit too much reality there. And it's one of my circumstances, if I'm trying to change between projects, I really don't have that well. Well, we tend to choose your own project.
So the way we get around it is using the Microsoft Teams page for each project, which has to be called a T number, which is then we will TRL process. And that Microsoft page, when you do it in Microsoft Planner, it brings back that SharePoint T number at that point. So everything then in this parent T number, and then you want to switch that to project, you can effectively unload that T number, put a new one in, and everything then changes to the other side. It's like having multiple virtual machines for the same thing for different projects. You can do that way. But if you lose connection to the network, for whatever reason, you forget about it, everything's gone then. Rely on that connection.
Yeah, so I think there's some good tools out there. It's just a case of working out which one to fit. I think what we came out of last time, a few months ago, the session we did with MLUG, was that it's really about picking a tool and just using it. And it's trying to pick one that embeds into how you work as well. So because the Jira and stopwatch, like that really fitted, that felt quite good, because the idea of just having something to start and stop to manage your time was quite neat. So yeah, I think that's the general point really, is trying to find something that fits in with how you work. But yeah, we'll move on from that one. Where we've got.
Just as a point to Jira now, 3 from the 10 users.
Yeah, that's all right. That's pretty good.
They've got a new project and make it all pretty.
Yeah.
It's confusing because now there's more options, but.
Yeah. Yeah. All right, we'll pick this one as the last topic. Great. So everyone's favourite one, probably. Right. What do people do with documentation? So let's talk about it from a point of view of when you start a project. So the point at which you start a project, what does your documentation look like once you sort of are moving through the project and once you complete the project as well, I guess. I guess people are documenting block diagrams. Is that one way people are doing stuff? Do you, obviously requirements are a big one. How do we keep them up to date and all that kind of stuff? I think that's a big challenge that we found is you have a set of requirements and start developing, things change. You go back and change the requirement document so that it reflects what you've done. We talked a little bit about this last time, but yeah, and how do you go about? Do you buy user guides and stuff and find that people use them, or are they just documents that float around somewhere and don't ever get looked at?
Actually, I use them again.
Yeah.
Customers never do, but I always make notes on how you fix this like this.
Yeah. Yeah, because what we've always found is that we do use guides, but they don't ever get used. So, yeah. Anyone got any good tips for you documentation, code documentation?
We do requirements gateway. I know you get it on, there's not much focus on requirements gateway. They're all in use gateway. I feel like we're making some potholes. We are currently using requirements gateway with our new. Up until about 3 months ago, we didn't have requirement documents. You might not be for any product that doesn't exist, it's requirement documents for any of this stuff. So it's a good
analogy. Verbal.
All that. So it's a good analogy for that to say polish on the website and chaos on the inside. And then certain things that development, which we can test this as well, the enterprise and it's 100% chaos. So we want to recently start getting requirement documents, and as part of that, we've started using requirements gateway for refactoring all of our software. Not necessarily just through NI tools as well, right? We've also tried to improve it to any other language as well. So that's design effectively.
Did you look at a few tools when you came to using the gateway?
Well, the advantage of requirements gateway is going back to the IT to install it. Like, if we've software, or look at any other tools, we've been getting that added, we're going to have to do the white language.
Yeah.
They opened other tools for it. We did try Jira, having things on back and forth to Jira and relay link, but the link wasn't reliable enough to be able to say where I come from requirements and know we can jump to that exact location. You go to Smash branches that you go with large projects, it wasn't really scalable.
The problem that was pointed out to me as well, which as soon as we start this, I totally get this and I'm responsible, is Jira's, what you put into Jira is really specifications for software, it's not requirements.
Yeah.
And that bridge is a bit of a hard job. Maybe it was obvious if someone said that to me, I was right through that. Well, that's requirements in Jira. You can't build requirements. You can only build specifications, and you've got to bridge the two.
It's more of a system requirement rather than software requirement. Is that what you mean?
Well, even a software requirement might be, you need to click this and do that.
Yeah.
It's like, well, actually, you can't build software from that. You have to take that and turn it into, so I need this bit of software, this bit of software. And most of the time, we do that in our head. But it means that, for example, if you put them in as requirements for Jira, you find you keep coming back to one, well, I've got a bit of that to do over the software and a bit over to do it here. And vice versa, if you're only putting specifications, it's hard to go back to what do we actually need to build and what is there. There's a fundamental bridge there. I think, again, there's two layers to this. I think there's the software layer and the project layer. The project layer deals with requirements. And so mapping between those two is tricky. It's not an automatic thing.
That's the part I find most difficult at the moment. I'm trying to formalize my processes, basically flow chart, just based on size and business requirements, that sort of thing. But actually get to your requirements custom or SRS, whatever you want to call them, how you go through there to, you can know Jira architect, how you actually then say, this is my user story, this is my story, this is my syntax. And actually just finding those is so much more difficult than when you actually sit still about it. You don't just go, oh, it's not much. It's sat that down, you know, it needs to do this, needs to develop it. Yeah, TikToks, you know, actually finding those is really, really difficult. But I think that in itself is quite interesting to talk about as a topic, because I have no good way of doing it at the moment. Bookmarks as well.
Bookmarks are good.
I agree because the people will probably see the code is either me or I give it to someone. I don't bookmark this. As long as you find a good, effective way to do that.
So is requirements gateway effectively like a bookmark on steroids kind of thing?
Kind of, it links back, so we've got links back into our Word documents, we'll have a Word document, we go to the plans, say things like, it must do X, Y, Z. You click the link in the Word document, the exact VI covers that particular part, and then you have the additional documentation there. So the big thing for us is we also get a requirements coverage score from it then, so you can see, as you go through these TRL stage gates, you can then say, oh, we've got 45% requirements coverage at this point, like also this is how much work we've done, because you obviously pick up all the easy ones, the number of options. Then you can say that at the end, what's your level of confidence in this business? Like we have 75% requirements coverage at this time. Like based on your requirements, we've done 65%. The way that our team operates, we effectively have almost works like a little internal consultant company inside of banks, we're not category specific, so our customers are integrated with that. So that's why we're having to enforce this with this requirement tracking requirements. So far, it's been okay. I have no problem with it. There's a lot of for it.
It gets a lot of flack.
There's a lot of flack on for it.
Sit behind the door and have to do it. It's alright. Works.
It gives you kind of grind out and you want to force people to document code in that particular way as well. So if someone comes to me and says, I've done this, now run it through the requirement scanner and have a look at it, it's got 5% requirements coverage. Like, no, I haven't done that. We haven't done it properly because sometimes people click straight to that section of tools. It is like the background.
The reason you do it is that's how the market is. They need to get fixed in that and can't just go through watches and go.
It does work.
It work.
It does work.
So 2015.
Yeah, it's pretty old. The problem I have with changing requirements documents to add new requirements, what they do is instead of just a 10-minute block, they just add them in, they look at their relevant, so then all the requirements shift back on them, then we do the requirements. I just have to more than one occasion, and you're like, we can software that. Yeah, and you're like, put it on the end, like, so now we can implement all our requirements and see where they're actually covering. So that's
it's a way of tracking the requirements, not a way of changing the requirements.
No, that's true, but yeah, it's more just to look at the requirements at the end, and then we also have a big split of software requirements that are the key. We have hardware requirements, and then we have software requirements that are EYS, SW, and those to keep them. So if they change the hardware ones, we might improve them on the software ones. You think that would be something sensible?
Right, guys, I've just had a word that the chap who's on next is going to throw on Skype, and he can't do anything later than our original time, which is in 10 minutes, so I think everybody would like coffee before we start that. So we'll just break now, and we'll come back in 10, and hopefully have the guy on Skype. So go grab yourself a coffee, and back in 10. I didn't see that.
It's just something like that.
Yeah, it's see me on Skype. Alright, shall I call it?
Hello, Chris.
Hi, how are you?
I'm good.
Awesome, you can hear me. This is good. Technology working at its best.
Okay, so you say you can hear me clearly?
Yes.
Okay, that's good. All right. One thing out of the way.
Yeah. Should we go with the screen share and see how we go with that?
Yep.
Awesome, yeah, I can see that.
Okay, is this resolution kind of all right?
Yeah, it looks good.
Let me just get into my virtual machine and pull up a few windows to see if these things are legible. Is this legible, for example?
Yeah, that's pretty good, yeah. Yeah.
All right.
Yeah. Awesome. Okay, well, the guys are just grabbing a coffee, and we'll be back in 5. So is that okay? We leave everything connected up, and I'll give you a shout in a bit.
Okay. So what I'll do is I'll wrap it up in 45 minutes. I'll skip one demo out because unfortunately I do have another engagement and I do have to run.
Okay.
In terms of I had a question about questions during the presentation. I normally when I present, I don't mind people asking during, but since this is remote, I don't know how that would work. Yeah, so either you could relay the question, or we can do the Q&A at the end. I don't know if you guys have a preference.
Yeah, I'll stand up at the front and I can manage that. I think if people have any questions, I can take them, or yeah. Should we play it by ear? I'll stand at the front. If people have questions, I'll try and communicate those to you and then go from there.
Yeah, I think that sounds very good.
Awesome. Okay. All right. Well, I'll catch up with you in about 5 minutes then.
Okay, awesome. Thanks.
Cheers. I'm speaking now. Microphone's in there. Hello, are you still there, buddy?
Yeah, I was still muted.
Sorry. Oh, cool. I'm really sorry to have to ask this, but how do I pronounce your name?
Oh, it's Mache.
Marquet.
When my wife tries to explain to people how to pronounce it, so it's like Ma like Mama and Che like Che Guevara.
Marche.
Glue them together and that sounds pretty decent.
Marche. All right. Apologies in advance then if I get that wrong.
No, it's when I get random sales calls, it's a joy to wait until they try to attempt it, then
Yeah. Pick him up. Nice. All right. I'll catch up in a sec.
Yep.
Yeah, definitely, definitely. Who are you working with then? Who's your sort of manager?
No, it's just for great fantasy. No, it's not supposed to be like I would give my answer to possible. Kansas always take people straight on.
Yeah. So how long have you been programming?
5 months.
Okay. You're very nice as well.
Yeah. Yeah, that's right.
Well, I'll go with coffee and get started.
Cheers.
Hello.
Hi, hello.
I've forgotten already. I've forgotten how to pronounce it already. I wouldn't even bother trying. I'm really sorry.
That's all right.
Right, I'm going to turn it up a bit because I think we're probably a bit low.
Okay.
Right. Okay. Do you want to just test the sound again? Just speak or maybe start?
Okay, can everybody hear me all right?
Yeah, that's good. That's good.
Okay.
Awesome. I'll let you do the introductions then and I'll pass it over to you.
Okay. Hi, my name is Maciej Kolosko. I am going to be presenting on ZeroMQ. All right. So let me just swap the display settings. So who am I? I'm a partner at Compose Systems. You might have heard of us. We're a long-time alliance partner with National Instruments, and basically we do consulting work, mostly in LabVIEW, but in other programming languages as well. I myself have been working with LabVIEW for probably more than 15 years right now, maybe going on 16. Yeah, I've worked in a variety of fields. I've worked in nuclear, medical, oil and gas, and I've worked in various countries. So currently I'm based in Canada, but I did live and work in the UK for about 3 years as well, back in 2010. Yeah, that's a fun memory. So what we'll be talking about today is how do you use ZeroMQ with LabVIEW, and how can you build a distributed system without a large team. And as I said to Chris, I usually, like, if anybody has any questions, please feel free to interrupt, and he'll just relay the question to me. So we'll just stop and answer it. I do, unfortunately, I'm running on a clock, so I'll try to wrap up in about 45 minutes. So yeah, let's get started. So the presentation overview. First of all, like, I want to discuss about the idea of distributed systems. I want to talk about how the distributed cloud systems are built, because these are the most popular distributed systems right now. What is ZeroMQ, and where is it available for use? I'll show you a demo of connecting current gen and NXG using ZeroMQ. Talk a little bit about how ZeroMQ can be used in the kind of systems we built with the use of LabVIEW, which really, for the most part, are not distributed cloud systems. And we're going to talk a little bit about stable versus unstable networks, if time permits. And if there are any questions at the end, we'll address those. So first, I want to talk about the aspects of distributed systems. So first of all, the distributed systems are basically componentized through services. Most of the time in distributed system, we segregate versus business capabilities rather than technology. We have decentralized government of the system, and we have decentralized data management as well as one of the properties. The systems are designed for failure, which means that if a particular service depends on another service and the service is not available, you need to design your system in a way that it should be able to handle that unavailability gracefully. And one of the trends that has emerged in the last decade or so is building smart endpoints and dumb pipes rather than the other way around, where the pipe is intelligent and the endpoint is dumb. So let's address the first bullet point that I had. So dividing components via services. Normally, when we have a monolithic application, which could be an executable, we would have that monolith and it would have certain functionality, which I've basically shown as these geometric shapes. If we're going to move over and basically redesign this monolith to be a service like distributed system, what we would do is we would focus on a particular service and create that as an executable, so that our services are running independently and they just communicate to each other if they need information. But that's how we divide system into components. Organizing versus capabilities, and this goes beyond the software organization. One of the things I wanted to highlight that a lot of software companies that used to build big monolithic application would divide their software teams something like that, where they would have a bunch of people who are good at the user interface stuff, people who would be responsible for business logic, and a bunch of people responsible for the database. So they would organize, for a monolithic application, it made a lot of sense to have a team specialized in a technical aspect of things. But when we're thinking about organizing business capabilities, we're going to want to not only organize our software in a different way, but also organize our teams in a different way. So right now, we would see that there would be teams that are responsible for different aspects of the system, but they would have people of different skill sets. And the advantage of this is basically they can iterate quicker. They are working on a confined functionality, and they're not really codepending on each other release cycles as long as they have interfaces to talk to their services that are consistent. Building for failure. Like I said, a lot of services that we build are they need to be able to survive if a service they depend on is not working correctly. And one of the examples of how this is being tested in some of the successful companies in the world is Chaos Monkey. Now, Chaos Monkey is a project that Netflix has created because Netflix infrastructure is basically built on microservices. And Chaos Monkey was, it sounds like a crazy idea, but it works very well for them because in order to test the availability of their system, what they do is they wrote Chaos Monkey, which is basically responsible for nullifying and switching off a whole bunch of services and making sure that the system works. And the thing that's very interesting is that they run Chaos Monkey not in their test environment, but on their production environment. So, and that makes their stuff resilient, right? There's nothing that's going to make you more willing to fix your issues and bugs if your stuff's not working on production. So I thought that was an interesting thing to mention as an idea. Now, why do we build dump pipes and smart endpoints? I think about a decade or so ago, there was this idea, especially in the enterprise application, of building the enterprise service bus, which was actually the opposite. The enterprise service bus was a very intelligent pipe where you could connect different aspects of a distributed system to this big enterprise bus, which was capable of handling translation between different protocols, and it was a very interesting concept from an engineering perspective. But I have this Dilbert comment that kind of describes how it really went down in reality. It was a little bit too complicated, and basically the trends have that's why the trends have moved toward basically simpler, dumber pipes and more intelligent endpoints. Okay, so now we're going to talk a little about ZeroMQ. How does ZeroMQ fit in this picture? Well, what is it? So it's not another message queue. It's not a daemon or a server. It is simply a library. It doesn't bring any additional dependencies with it. If you use ZeroMQ on a Windows machine, all you need is literally one DLL library, and that's it. It's a very lightweight socket system, and some of the ZeroMQ's documentation even refers to it as sockets on steroids, which I think is a very fitting description of what it is. And it was built for financial markets to handle high volume of messages. So it's definitely quite capable of transferring data and transferring a lot of messages. So where is it available to get? So the language bindings, that means like the adapters for ZeroMQ that consume the DLL that I mentioned, are available for over 50 programming languages, which include C#, Java, C, LabVIEW, Python, F#, Lua, PHP. And there's many more. I left in a link where you can kind of look it up if you're interested. Java C# stack is supported as direct implementations. So basically, ZeroMQ has been implemented in those languages directly. All the other bindings basically rely on the C++ core library and provide wrappers to it, including the LabVIEW adapter that I'll be talking about. And the supported operating systems include Windows, all kinds of blends of Unix and Linux systems, iOS, Android, and VxWorks. So ZeroMQ bindings for current gen. So a lot of credit goes to a gentleman called Martin Spursy, who's the author of the current ZeroMQ binding for ZeroMQ. His code is available to SourceForge, and basically he created back in the day, back in 2010, an adapter.
We're struggling to see a little bit of your screen. I don't know whether we can just sort it out quickly, but I'm not sure that whether it's your end or my end.
Okay.
So we can only see up to the GEN. So we can.
Current gen, yeah, current generation.
Is that the edge? We can't see the bottom of the slide then.
Oh, you can't see the three like a.
You can see two blocks. Can't see much of the red bit on the right there.
So this stuff is cut.
Yeah, can't see your mouse.
I can try to change the resolution to see if that helps. Do you have a different resolution? Do you have a specific resolution in mind?
I'm not sure.
Because I'm working with this. I can go lower if that will help.
Do you want to try it and see what it looks like?
Okay. Is this any better? Can you see the whole slide now?
We're still looking at your resolution screen.
Oh, that's quite weird.
Do you want to stop sharing and start sharing again, see if that solves it?
You know what? I'll try to share the second screen that I have, and we'll see if that helps.
Okay.
Oh. It doesn't seem to detect my second screen at the moment. I'm not sure if this is any better. Can you guys see the screen anyway? Because I don't see the yellow outline at the moment.
No, it's not. No.
Oh. That's a bit of a bummer.
Shall I end the call and start a new call up and see if that...
We could try that, sure.
All right, I'll call you back.
Hello?
Hey.
All right, trying again.
It's got a grey screen now. I should have left it how it was, right?
Yeah, that's...
You always want to try and fix it.
Well, unfortunately, for whatever reason, it's not sharing the screen at the moment. I'll try to revert back to the resolution that I had previously.
Yeah.
I don't. It doesn't seem like share screen options working for me at the moment. Is there any chance we can switch over to Google Hangouts real quick?
Yeah, I don't think I've used that before, but yeah.
Okay, I'll send you an invitation, and we'll see if we can pick it up from there.
All right, cool. Yeah.
Hi there.
Okay.
Says I'm sharing.
Yeah.
Is this any better?
Yeah, that's awesome. That's awesome.
Okay. All right. So I'll speed up right now. So now that we got to ZeroMQ itself, what is the binding for current gen actually, right? So it basically consists of 3 layers. One layer is the actual ZeroMQ library that I've mentioned previously, which is C++ base. There is an adapter that's written in C++ by Martin, which basically makes it easier for LabVIEW to interact with the API that's available right off out of the box for ZeroMQ. And there's a LabVIEW interface that's class-based. And I'm going to talk only about 2 classes, the context class and the socket class, because they're the most prominent, and they're going to be enough for us to have a reasonable discussion about how to use ZeroMQ. So the first class is the context class, and what it is, it's thread safe, and it's also responsible for managing input-output threads. And then there's the socket, which is a very important class, and that one you create sockets on both ends, and it's used to manage endpoints. One of the things that's important to remember, it's not thread safe. So you shouldn't be using a socket requesting and responding stuff in different threads, because all kinds of bad things can happen. But there's ways around it. What I want to show you now is basically an example of connecting current gen, next gen using ZeroMQ and the API with a very simple request respond pattern. And then we can have a discussion about the process of porting a portion of the ZeroMQ to next gen. But since I'm kind of low on time, maybe we'll skip the process of talking how this porting works and just focus on the example. So, all right. So I have a current gen and a next gen VIs. So right now what's happening is in next gen I have AVI that's sending my test message to my current gen VI. Can you guys read this stuff? Is this
not that well, but
not that well?
no.
Some numbers are changing.
Yeah, we can see it changing. Yeah.
Okay, because one of the things I wanted to demonstrate is that what's happening right now is basically my ZeroMQ code that's running on current gen is sending this message, which right now says test, whatever, and it's sending it as a string and rolling it back, and they're just basically communicating with each other with like every half a second they send each other the message. So this one is, they're working in a request response pattern. One of the things I wanted to make you aware, if you're not already, is that the string encoding between the next gen and current gen has changed. And the default encoding for next gen is basically UTF-8. So if you use some symbols that are not normally basically that are encoded in UTF-8, the current generation LabVIEW by default, and these are all behaviors that can be changed in both environments, right? But by default, the current generation LabVIEW is going to think it's getting ASCII strings, and it's going to misinterpret that. But like I said, you can fix that on either end. So if I change the encoding to be ASCII explicitly on the current gen end, things are going to start working back together. So how does this stuff work, right? So let's just take a look at these simple examples. So the current gen code is basically, and I'm using the current gen basically 0MQ binding created by Martin. So at first I create a context, then I create a socket, and this socket is going to be a responding socket. So what it's expecting is it's going to receive a request. So it receives data, does something to the data, and here I'm just like adding some information about the current loop iteration, and I'm sending it back as a response. Now the code on the next gen side, I basically, in order to get this to work, I basically took the 2 layers of the C++ code that was provided in the current gen and just made wrappers inside next gen to make this work. So I also have the same construction of the 0MQ context. I create a socket. The difference between this is a responding socket, this is a requesting socket. And the one difference is that this socket is set to bind, and this socket is set to connect. We'll talk about it a little bit in a minute. And here the pattern is very similar, only the order is received, because this one receives data first and then sends it, and this one sends data first and then receives it. And as you can see, because there's another change in next gen that's pretty significant. Strings are no longer because everything's UTF-8. Flattening stuff to string isn't. It's not exactly the same behavior as we had in ASCII. So I'm flattening stuff to a byte array. So basically that's when the encoding is important, right? But apart from that, the interface looks pretty much the same. And with this code, what I really wanted to demonstrate, there's really not much going on. There's like some initial code to start the communication, some initial code to stop the communication. But the good thing about this is that once you start one side of the 0MQ code, as soon as the other part starts working, sorry, my stop button was just enabled. Oh. Huh. Nothing like a great demo. I just wanted to prove how this all is going to come to life with no issue, and it does not. I must have screwed something up.
I found when using that library that the 0MQ context can hang.
Can somebody? I didn't clearly hear the question.
So when using that context?
Yeah, when using the 0MQ, I found that the context actually launches something in the background. So
yes.
it can hang. That's what I found.
Yes, so like I said, the context is responsible for handling of all the I/O threads. So usually you would want to have one per the entire application run. It's possible to create more, but I didn't really find a need to do that. I'll be able to demonstrate this with my next example. So maybe let me just like move on to the presentation, and I'll come back to one more example that I have, because I have about 15 minutes and a bit. Okay, I hope this still works.
Yeah.
So what I wanted to do is discuss a little bit about the real-world system example. I was talking about the cloud-based systems quite a bit in the beginning, which is, but I wanted to talk to an example of a system that I'm currently working on that is using this concept. And so the system that I'm working on it has nodes distributed on a local area network. Some of them are powered by LabVIEW current gen. Some of them are powered by C++. Some of them are C# and .NET. And this is like the basic overview of the system, where it's basically an assembly line where there are a whole bunch of stations that have separate control PCs which run a LabVIEW service that's going to be executing the work of a station. There's multiple of those. There's a bunch of robots which are controlled through an application that's written in C++. And there's a lot of vision inspection going on, and the vision inspection for this particular job is being done in a .NET environment. So the way the communication works is that the stations, once they're done with whatever they're doing, they send a 0MQ message to the main LabVIEW control program, and then it's over 0MQ messages as well, is able to interface to a separate service that handles vision, a separate service that handles the actual robot motions, and is able to report back and relay the messages back. Now, one of the things that we found when we were working on the system, that when we do LabVIEW to LabVIEW communication over 0MQ, one of the easiest ways to handle things was to just take LabVIEW classes, because we used classes as messages, flatten and unflatten them to string, and just deserialize them on the other end and reuse them that way. For talking between LabVIEW and something else like C++ or .NET, JSON seemed to be a very good way to format our messages, where we basically flatten. In this case, I put LabVIEW object, but I'm really using LabVIEW controls. Flatten them to we flatten them into a JSON string, and then deserialize them as a C++ or .NET object on the other end, and work from there. And the communication scheme that is really one of the things that I've already discussed is the request-reply sockets. There's also one more that's pretty popular, is the publish-subscribe. There's more than that. There's push-pull, and there's more, but I just wanted to focus on a few basic building blocks and kind of discuss what can one build with just knowing those two socket types. So one of the things that's pretty good is that if you have a request and a reply socket, what you can do is you can easily add more requesters and more responders, and 0MQ library itself is built in a way that you don't really need to worry about adding some automatic marshalling code that's going to handle things properly. The code that's built within the 0MQ, it's going to allow you to do that. So if you have a request from one node and it waits for a reply from another node, you can create a request from the next one, and it'll just be buffered. And once the reply is done, things are going to move smoothly without you really needing to think about it. With the publish and subscribe, I think it's a little bit more obvious, where you have as many subscribers as you want to a single publisher. But this works also really nicely and allows for building of systems that are scalable quite easily without the need of writing complicated reconnectivity code. And this is one of the examples of, like, if you just use these kind of sockets, what you could do is create a system that's kind of like this, where you have multiple clients that have a request socket on their end and have a response socket on the server end. They have a publish socket on the server end and a subscribe socket on the other end. And this could represent a lot of architectures, but this, for example, could be an example of a online multiplayer game. Yeah? When you have multiple clients that create some requests, they get some responses, and they get the state of the actual world of what's going on through a publication. Whenever something happens, a publication is being sent out, and you can kind of get yourself aligned with things that are going on, only by knowing these two socket types. And there are more socket types available. So I'm looking at time here. I think I'm going to skip this slide. This is just a slide where I wanted to also say how using a simple request and reply, you can create synchronous operations. If you want to have an asynchronous operation with a promise, you could use a request and reply a confirmation of a receival of a message. But then if you care or not, you can have an additional publication of subscription. Now, the one last thing I wanted to talk about and go back to one more demo that I have was stable versus unstable networks. So, and if you remember in my previous example, I had one of the endpoints was doing a bind operation and the other endpoint was doing a connect operation. And I just wanted to briefly discuss what's the difference. So there is not much of a difference, but the major idea behind the bind and connect is that there are going to be some nodes in your network that are more stable, which means that you expect them to be where they are most of the time, while there are going to be nodes that are unstable, and they are going to come and go as you please. And that's when bind versus connect is used. If you have a stable node, you want it to be a node that you bind to. If you are the unstable node, you want to be the node that connects. Yeah. So I'm going to demonstrate this example where we have a stable node, which is a proxy. And this is using two more socket types, a router and a dealer. And there's going to be a bunch of requesting nodes and a bunch of responding nodes. And the router and the dealer is basically the stable point of the network. So let me just jump into my VM one more time. And I hope I'm not going to have to restart NextGen because it seems to be pretty unhappy with me. But let's see. I am using a older version of NextGen, yeah, so I wouldn't hold that much against it. It's 3.1. So what I'm going to do is I'm going to start a proxy. And I'm going to start an image serving service, or actually two of them. And one of them is going to serve pictures of a Caribbean island, and the other one is just going to serve some pictures of a European city. And there's going to be some client nodes that I'll start up right now. I think I'm going to have to restart NextGen. Sorry about that. Yeah, something doesn't seem to agree with it. So this node is pretty similar to the previous node. The only difference is that what's being serialized and sent and received is basically an image. So as a byte array, we're just flattening and unflattening images. So I'm going to run. Okay, so what's happening now is I have two nodes that are responding, and they're responding with different images. And I also have 3 nodes that are requesting, and what they are getting is, because everything goes through a proxy, they don't even know, but they get connected to either one or the other. And basically the proxy handles the requests. So that's why you will see that on the requester side, depending on how things are going, you're either going to get a picture for one of the servers or the other ones. And the good thing about this architecture is that if one of the servers goes down, the clients, if the throughput can be still fulfilled by the network, the clients are still going to be, they're not going to experience a problem. Everything is still working. They are just hitting up only one of the responders. Right? And if the node comes back online, now we have 2, we can call them server nodes, serving information, and they're back online. Now, the one thing that the only argument that I wanted to, or the only thing that I really wanted to underline here is that everything is going through this stable point in the network, which is our proxy. So if the proxy gets shot, everything stops, right? Everything stops, and the whole system is just pretty much waiting. If the proxy gets back up again, the system comes back to life. And this is the thing that I failed to show you on the first demo, because I've experienced some issue here. But basically everything reconnects gracefully, and there isn't any sophisticated or complicated code in order for that to happen. It's the ZeroMQ's ability to basically handle the binding and reconnecting automatically for you. Okay, so that's all I had in terms of demos.
So is that router LabVIEW code you've written, or that's just part of the library as well?
The next gen stuff, or
the router, the proxy, sorry.
The proxy code that you have.
Oh yeah, the proxy code is there is a proxy construct in ZeroMQ itself. So there are just a couple of wrappers here, and like I'm showing here. So what I basically did is I created a router socket and a dealer socket. Here, I gave them a port, and that's basically it. I took those sockets and I just run them in a separate thread here, so that I can have them going. But yeah, that is available in the LabVIEW API. You can basically run your own router stuff, and this does the equivalent of the same code in C++ that I'm showing you. So it's possible with the LabVIEW wrapper to do this stuff. Does that answer the question?
Yes, thank you.
All right. So the last thing I'm just going to mention, and I can handle a few questions, and then I unfortunately have another appointment I need to go to, is types of transport. So the types of transport that I use right now everything was TCP based. There are different. There are basically 3 more transport types. One is inproc, and the other one is inner process communication. And there's also PGM, which is for multicasting. That stands for pragmatic general multicast. If I remember correctly, I think IPC is only available on Linux, but if you want to use the same, you would just use a loopback and TCP if you want to use that on Windows, because they're performance-wise, that's your best option. But there are a few other options of using bindings that don't necessarily go through the TCP protocol. And if you'd like to get in touch with me or ask any additional questions, you can reach out through this email, or you can just hit up composesystems.io and leave a message. The examples that I had here, I'll put on labviewcraft.com, which is basically our blog. And that kind of concludes the demo. Sorry for a couple of mishaps, technical, but if you have any questions, go ahead.
Anyone with any questions? There's no one picking anything up here, so thanks very much for connecting up, and it was great to have the presentation.
Hello? Oh. Sorry, I lost audio there for a second.
There was no questions just then, so thanks very much again for presenting. It was really good.
And thanks for having me, and have a good afternoon, guys.
Yeah, have a good day. Take it easy.
Thank you.
Thanks a lot.
Bye.
Bye-bye.
Anyone sort of can see a use for that in what they're doing? What are you thinking?
Thinking of not having to deal with reconnecting between compact radios and
hosts,
but the structure you showed, I'm guessing you'd have to recompile them with the library on Linux for that to work. That's more or less.
Yeah.
You have to go through an overlapping side to adapt. That's generally not too tricky though. But no, the idea of having, that's what I've had in my head is, even if it's straight console, then the idea of being able to mix those, do publish subscribe easy as well.
All with that one library.
Yeah.
Just cover it all. It looks pretty straightforward in the way that it's coded as well, and not too complicated. So, yeah. Awesome. All right. Well, that kind of concludes things. I mean, you can stick around and network chat, whatever. Now, just a quick thank you to Ian for helping us out with hosting, and thanks everyone for coming along. And the next meeting, we do have a date, but I cannot remember what date it is, so I'll make sure I share that afterwards. But we're looking for speakers, looking for venues, so if you've got any ideas, something you want to share, then give us a shout. Always open to suggestions. And that's a wrap, I think. Thanks very much.
That's great.
It looks really appealing because they solve problems that we don't generally have, and that reverse proxy example. It would let you load balance the processing across multiple systems. The sort of systems we work on is yeah, exactly. Actually, never know the application come up, but
don't need it.
yeah, I don't
Maybe there's a team down there, a team as well.
These are what? Associate principal.
yeah, that's
really?
true, yeah, if you want
Yeah, I'm came off work for a little while and then now he's back as an AP. With the restriction, like, all right, he's going to be in charge of like safety and stuff like that.
Okay.
I've done it.
Because I met up with Sam a few months ago, and he said he wasn't really managing a team anymore.
No, he doesn't. Right. No, Charlie and I manage the team prominently with my just an AP that works.
But again, it's something like that.
Within test and stuff.
Because right now it's still a
Yeah, if there was a test that specifically like safety and stuff like that. Or maybe on the safety.
it is interesting. Disappointing.